Hello, hello! Welcome to Day 2 of Intro to Java Fundamentals. This is a free 6-part course by the Auxi Project aiming to introduce you to some of the fundamentals of Java and how to think like a programmer. For a playlist of all the parts in this course, you can click in the link in our description box below, and to see more videos just like this one, you can visit our channel. Alright. So today's lesson will be a bit more theory-based, so while we won't be getting into any programming today, we are going to be learning a lot about what goes on inside our computer when we code. To start it off, we're going to be learning about operators. We have arithmetic operators, assignment operators, relational operators, and logical operators. Then we'll talk about variables, and at the end we'll do a little activity where we try counting in binary, just to understand a little more about how the computer thinks. So without further ado, let's get started. Operators are basically symbols in Java that we use for, well, operations. In general, there are 5 categories, but for our purposes, we're only learning about the first 4, just because they're a bit more applicable to our code. We'll be using these symbols a lot. The 5th category, so bitwise, is a little out of our scope of content. It has more to do with binary code, so 1s and 0s, which we'll learn at the end, but we won't be using those symbols at all. Of course, if you are curious, you're free to do some extra learning. I would highly encourage it. You'll find that a lot of these symbols might be the same across languages, so if you know Python or maybe C++, that'll really help you out in this lesson. Alright, our first category of operators are called arithmetic operators. These are basically symbols used to do math in Java. I'm going to be pulling up another window so we can take some notes. So I've opened up Replit, and if you need a little refresher on what that is, go check out the last video. There I run through what Replit is and what an IDE is and just how to use it, all the basics. Okay, let's get started by declaring some variables. Now you may not know what variable declaration is yet, and that's okay. I'll run through that later on in the video, so just hang tight for now and just copy along. Alright, we've declared 2 variables a and b. One is equal to 12 and one is equal to 5. Now, the first operator we're going to learn about is called the addition operator. And as the name suggests, it's an operator that does addition on 2 numbers. So we're going to declare a new variable c, and that c is going to be equal to a plus b. Let's write that up here. It's common convention to declare all your variables in the tops, just so it's easier to call later on. And we're going to set it to 0 just temporarily. This number will change later because it is a variable. And when we use the addition operator, we're going to add a and b together, and that we're going to make equal to c. So c would be equal to a plus b. And that's as simple as it gets, really. Now, if we run this, we'll have no way of knowing whether or not c actually became a plus b because we didn't tell the program to print anything out into the console yet. So even if it was doing this calculation, we wouldn't know it. It's kind of like how if you have a math problem and you solve it, but you don't write anything down, your teacher would have no way of knowing whether or not you actually solved it or not. It's kind of why they always ask you to show your work or write down the answer in this spot. We're going to ask the computer to do the same thing here. We're going to have an output line and ask the computer to print out C. So let's give it a try by running our program. And sure enough, it gives us our answer of 17. Great, so that's our addition operator. Next, we'll do our subtractions. So let's now turn c into a minus b. And again, we have to get it to output it. And we'll run our program. Let's just comment out this top part so we don't get confused. Right, and again, it does give us our correct answer of 7, which is just 12 minus 5. Now, something you might be wondering now is, can our computer do negatives? So what if we did 5 minus 12 instead? And a surefire way to find out is to give it a shot. So let's try b minus a this time. And you'll notice I didn't really include spaces in this one because spaces don't really matter. If you're coding, once you get used to coding, you'll find that a lot of times to save time, you'll just skip the spaces altogether. But the spaces do make your code a bit easier to read. Let's run our program. And b minus a is -7, which means that yes, our computer can calculate into the negatives. It's really helpful. Okay, next up, we'll do our multiplication operator. And our multiplication operator is not an x, but rather a star. It's called an asterisk, I think. Yes, an asterisk. And that's just the symbol for multiplication. So let's have it printed out, and to save time, I'm just going to copy and paste what I have in line 14. And remove these 2 indents for proper formatting. And let's run it. 12 times 5 is supposed to be 60, and that is exactly what we get here, so perfect. Everything's working as expected. Okay, let's do division next. Now, here's where it gets a bit tricky, because we know that 12 divided by 5 doesn't give us a nice whole number. So our computer is going to do something special. Let's try it out. When we run it, our computer actually gives us 2. That's not because it's doing math wrong or anything. It's because as an integer, it can only store integer values. So when the computer does the operation of 12 divided by 5, it does, long division where it carries the 1 and all that. And so it gets to 2, and then that's when we as humans would start calculating into decimals. But our computer, unfortunately, can't do that just yet because we've set our value c to be an integer. I'll talk more about this when we get to variables, but what you have to understand is the computer just cut off everything after decimals. It didn't round or anything, it just cut it off, and that's called truncation. And that's where modulus comes in. So modulus might be a bit harder to grasp for some beginners just because it's not something we use normally in daily life, but it is used a lot in computer science, so it's really important that we know what it is. Modulus is basically an operator that gives us the remainder of a division. So let's write that down. So what this looks like is when we divide 12 by 5 and we divide only to the whole numbers, we end up with a remainder of 2. And, I guess this example makes it a bit hard because 12 divided by 5 is also 2. So let's change up our number a bit. We change a to be 13. What we get is a remainder of 3. Now, this means that when we do 13 modulo 5, we should get 3. let's give it a try. Modulus is represented by the percentage symbol. So we'll put that in. And we'll print out C. Oh, we get 2 on the top because we forgot to comment out line 22. But you get the idea. What the computer printed out here is the modulo of A and B. So it worked. Hooray! Now there's one more topic we have to cover. This might look a bit weirder because it is a computer science exclusive symbol, but they're called incrementers. And incrementers have a counterpart called decrementers. But basically they're like addition and subtraction, but special in a way. Let's give you an example so you kind of understand a bit better. I'll declare a new variable. Let's start off by making a variable called number and setting it to 6. Now, an incrementer is basically a symbol that will increase a number by 1. So it increments it by 1. And to use it, we're basically going to just put it at the end. Now, to check out what it did to that number, let's print it out. It would also be good to comment out the top 2 lines so we don't get confused later. We'll run our program, and we've set our number to be 6, but what comes out is actually 7. That's because when we did this plus plus thing after number, we told the computer to add 1 to 6. So what we basically told it to do was make number equal to number plus 1. So 6 plus 1, which is 7. Now decrementers work the exact same way, except you're decreasing the value this time. So now let's minus a number. So I'm gonna have to comment out line 31 because if we add 1 to the number and then subtract 1, there won't be a change and it'll be a bit confusing. Okay, now what our computer should give us is 6 minus 1, so 5. And it does. Now that we've covered incrementers and decrementers, there is just one last thing we have to talk about. And that is the good old order of operations. Now in school, you may have learned an acronym for remembering what order to do equations in. Now for me, I learned BEDMAS, which stood for brackets, exponents, division, multiplication, addition, and subtraction. Now in computer science, it's very similar, except there's an extra 2 places where an incrementer or decrementer could be added. So what the acronym turns out to be is plus plus BEDMAS plus plus. Now you'll notice that these incrementers can go either before everything or after everything. So to illustrate this, you can actually choose to put the incrementer before a number or after a number. Earlier with the examples, we were doing it after the number, but you can totally do it before it too. And it'll do the same thing. The computer will still add 1 to the number, but it'll do it in a different order depending on which position you put it in. So in line 42, I've put the incrementer after number. So in an equation, the computer would do all of this first, so all of the brackets, exponents, division, multiplication, addition, subtraction first, and then it would go to the incrementer, and then it would add 1 to the number. Now, if you put plus plus before number, it would do plus plus. It would add 1 to the number first before doing any of these. Now, this is actually really important because it can change up your code sometimes. To give you an example of this, let's set up an equation. So I'm going to read all of this. Don't worry, the notes will be available with the slides and the link below. We're going to make a new variable. Let's call it second number. And my casing is very peculiar right now, but don't worry, it will make sense later. We're going to make an equation, and we're going to do 5 times number plus plus. Now, in this case, because of BEDMAS, what'll happen is the computer sees this equation, and what it does is first, it will do multiplication because I've added the operator at the very end of number. So it is, in this case right now, the one highlighted in blue. So it'll do multiplication first, which means it'll multiply 5 by 6 before it adds 1 to number. So then it turns number to 7. And because of that, second number will be 30. And to check if that's the case, we'll print it out. Oops. And it is. So what happens if we put this plus plus before number instead? Well, according to our order of operations, it'll now do the plus plus first, so it'll add 1 to number first, which means it's now 7 before it does multiplication. So now when it's multiplying, it'll be 5 times 7 instead of 5 times 6. So we should get 35 this time. And we do. Now, this plus plus is just a placeholder. It can also be a minus minus, so this is also completely valid. It's just plus plus. It's a bit more fun to say than minus minus BEDMAS. But if we try the decrementer, it'll still work the same way. Now, before we run it, let's run through some of the logic. What happens here is because the decrementer is before number, the computer does it first. So it'll subtract 1 from 6, which means it'll be 5 times 5. And it gives us 25. Wonderful, so everything has been working as predicted. This category of operators are the easiest to understand. Let's move on to our next category. Now we're going to be talking about assignment operators. And we're going to be hopping back on Replit. Assignment operators are operators that assign numbers to variables. So we've actually already been using them this whole time. Whenever we said A equals 13 or B equals 5, we've been using the equal sign, and that equal sign is one of the assignment operators. Now, there are a few other ones that we can use, and they're mostly used for shortcuts. So in coding, a lot of times you'll have to add things to stuff. So let's say you had to make that equal to A plus, I don't know, something like 6. So you needed to add 6 plus, in this case, 13. It is quite a bit for us to type, and luckily for us, we can take advantage of BEDMAS to get a shortcut. Because remember, bedmass is plus plus, bedmass plus plus. Now, when we run operations, there is one last thing that we have to add to our little order of operations thing, and that is the equal sign. The equal sign runs right before the last plus plus. Now with this new knowledge, we can make a little shortcut for ourselves. Instead of writing a is equal to a plus 6, we can just do a plus equals 6. And that'll mean the exact same thing, because the computer, it'll do addition before equals. So it'll first add a plus 6, which is 13 plus 6, so 19, and then it'll make a equal 19. Which is really handy, because a lot of times your fingers get tired after typing for a while. It's nice to have a shortcut once in a while. The same thing can be done for all of the other arithmetic operators. So if we wanted to do a is equal to a minus 6, we could just do this. And the same for multiplication. And division, and even modulo. So it is pretty handy. Now, you're free to run this, but note that your answers will not be, it will not always be 13, because after you make the first changes, so over here at line 9, I make a plus equal to 6, so it would be a, which is 13, plus 6, which is 19. Now, at line 10, when the computer goes down here, a will be equal to 19, so it will actually run this equation with a being 19 instead of 13 like we had declared it up here. That's just an important thing to note. Because it is a variable, it can change. Our next category is the relational operator. And these operators are a bit different than the other two categories, because when you use them, the output is actually either a true or a false instead of a number. So to demonstrate this, let's go back to Replit. And we'll clear out what we had before. Okay. So, we'll need to create some variables to demonstrate. So let's go ahead and declare our variables. Let's make a variable A, 7, variable B, equal to 11. All right. The first one is our greater than symbol, and that's just a little crocodile-like arrow. When I was in school, our teachers taught us that these arrows could be thought of as crocodile mouths. So whichever number was greater would be the number that the crocodile wants to eat. And so the crocodile would be pointing towards that number. So I'm passing this forward, I guess. When we use the greater than symbol, it'll look something like this. We'll have a condition, and then we have A is greater than B. Now, the computer will check if A is greater than B, and if it is, it'll print out true, and if it isn't, it'll print out false. Now in our case, because A is 7 and B is 11, A is actually smaller than B, so it should print out false. We don't have any way of knowing right now because we're not asking it to print out anything yet, but let's do that. Let's make it give us some output. We'll just drag this down here. And we'll run the program. And it does. Wonderful. Okay. Our next symbol is the less than symbol. And it's just the arrow but facing the other way. Let's try printing that out. So I'm just gonna, for the sake of time, copy this and paste it down here. I'll just make this small change to the symbol. You can run it. And it should give us true. Because 7 is indeed less than 11. Yes, perfect. So now we have this. There are a few other ones that are kind of similar. There's a greater than or equal to. And what this looks like is just the greater than symbol right beside an equal symbol. And order does matter here. Don't put your greater than after the equal, or it might be a bit, well, it's good to stick to convention is what I'm trying to say. With our example now, it should give us false. But if we want to illustrate this a bit better, let's make them both equal to each other. In this case, we should still get a true. Great, and we do. One more category, one more symbol to go through, or two more actually. Less than or equal to. If A is 7 and B is 7, it should still be true. It is. Oh, it printed out twice because it ran 14 and 17. Okay. Next up is our equal to operator. And I'm sure you're already getting some ideas of what it might look like. But if the equal to operator was just a single equal sign, that would become a problem for us because this sign is already taken. In our last category, the assignment operators, this symbol, this single equal sign, meant something was assigned to a variable. We used it up here in line 4 and 5. So we can't actually use it again for an equal to operator. And so what people have very creatively decided to do is add a second equal sign after the first one to mean equal to. And this difference might be pretty confusing at first, but just know that these are two completely separate operators. Equal is not the same as equal. What an equal to does is it checks if a number is equal to something. So right now A is 7 and B is 7. So if we asked our computer to check that statement, so if A is equal to B, it should print out true. and it does. Now if we change B to something else, say 9, it is no longer going to be true, so it'll print out false. All right. Now, to complete this pair, there has to be a not equal to symbol. So what that looks like is instead of an equal equal, it has an exclamation before it. And this exclamation is the computer symbol for not. So let's try it out. If A is not equal to B, it should print out true, because right now A is 7 and B is 9. Great! So that's it for our assignment operators. It's a lot to get your head around because we've learned so many symbols today. But there is still a category left. Bear with me, there are just 3 more operators to learn. This next category is the logical operator, and it is used to combine 2 or more conditions. So it does get a bit more complicated because now we are going to start using multiple operators or multiple categories of operators in one conditional. So let's clear this out. We'll keep our variables. For this category, there are 3 different operators: the AND operator, the OR operator, and the NOT operator. Now the AND operator is represented by 2 AND signs. The OR operator has 2 of these long lines, long vertical lines. They're not L's. And the NOT operator, like I said earlier, is just an exclamation mark. All right. So what this looks like is, let's say we have 2 statements or 2 conditionals. So we want to check if A is equal to 3 and if B is equal to 3. Right now we have 2 conditionals and we want to combine these. So we want to check if A is equal to 3 and B is equal to 3. What we would do is combine these on the same line, then use an AND operator to connect them. Now, it will give you an input or an output of either true or false. In this case, because A is 7 and B is 9, both of these conditionals are false, so the computer will obviously output false. To show you that, let's make it give us output. Oops, no quotations here. You definitely do not want quotations. Quotations show text. And so we're going to run this. And it'll say false, because both of these statements are true. Now what if one of them was true? So what if B was 3 instead? What would happen is it'll still give you false, because what this AND operator asks is whether both of them are true. They have to both be true in order for the computer to output true at the end. So if we wanted this to give us true, we have to change A to also be 3. Yep, true. Alrighty. For the OR system, it's kind of like AND, except this time only one of them has to be true in order for the computer to output true. So in this case, even if A was, say, something like 8, so not 3, it would still give us true. That's because B is true. So now if they were both not 3, then it would give us false. To explain not, I'm first going to talk a bit about true and false. So true and false are, well, as you can imagine, opposites. And when something is not true, it is false. And vice versa, when something is not false, it is true. And so if we replace the not in my sentence with an exclamation mark, that's when it becomes a command that we can put into our computer. So if we tell it to print out not true, it's going to do the opposite of true, which is false. So what should happen is the computer will output false. The same is true the other way. If we tell it to print not false, it'll print true. That's it for operators. So now we have 3 different types of boxes that we can use to store our junk. But the problem is there is actually one more type that doesn't fit any of these 3 boxes. So I guess I was lying a bit when I said that the string could store everything. Right now, our 3 boxes won't be able to store a number like this, a decimal number. I guess you could put this in the string and it would still work, but the problem is what the string stores is just the characters. It won't store the value, so you won't be able to use this number in a calculation if you stored it in a string. What we can do though is get a type of box called a double. Let's name it variable 3. Now this double is a pretty big box. It's bigger than an int, so it is capable of storing, oops, you don't need anything to wrap it around. It is capable of storing decimals, so multiple numbers. Now, if we were to use this variable 3 in a calculation, it would work fine. So let's give it a try. We'll add 3 to this number. Well, that might be a bit confusing. Let's add our int of a. Oh, that might be even more confusing. Let's just add the number 2, a nice number. Okay, so we have variable 3, which is whatever the heck this is. Then we want to add a 2 to it. So what it should give us is a 3.12345. Now in order for this to work, we have to actually store it in another box. So we have to store our answer in another box, or else it would just be free floating and nothing would really happen. So let's create another box. Now we have to use a type double box because we know our answer will also be a decimal. So let's name our variable, sum, because it's the sum of variable 3 and 2. Then we add our assignment operator, and now everything's perfect. So in this new box that we've named sum, what's inside it should be the sum of variable 3 plus 2. Now we don't have any way of checking unless we get output, so let's print it. And we can run it. It should give us 3.12345. And it does. Now, I'm going to show you what happens if we tried to store this 1, 2, 3, 4, 5 in a string and then we tried to add stuff to it. So instead of variable 3, let's try adding variable 2, which is the box with the string. It'll give us an error because we can't, right now, the computer reads the 1.12345 as a word. So we can't add numbers to words. It doesn't really work like that. That's why we needed this double box in order to do calculations with decimals. Now here's another interesting thing to explore. What if, back to our new box of sum, what if instead of buying a box for double, we actually made an int? So we tried to store our answer in an int. It would give us a problem right away because the computer knows that we're working with decimals here. And so anything involving decimals can't be stored in integers. So it has to be a double. All right. So that's an overview of variables, or of adding with variables. There is something else you can do actually. You can perform addition with two strings, and it'll look a little something like this. So up here, let's delete this. Okay, up here we have our box called variable 2. Let's say we wanted to concatenate two strings together. So we wanted to combine two strings together. Now let's clear out our space for this next part. Concatenation. Adding strings together. So let's say you wanted the computer to output a sentence that tells people what their favorite animal is. So you would have a sentence that said, my favorite animal is, and then you would want to put a variable here for whatever your favorite animal is. What you can do is, let's start at the top. We'll declare a variable, a string type variable, and we'll name it favorite animal. Now we're going to make this blank right now, so let's just leave it empty. It's just an empty box. What we can do is add this favorite animal string variable into our sentence just with an addition sign. Now, if we make this text, so we'll wrap it in quotation marks to make it text, what we can do is output it, print it out in the console, and it should print out the sentence. Now favorite animal right now is empty, so you can see that over here it just ends up my favorite animal is, which is a bit awkward, so let's fill up our box. Let's say my favorite animal is a giraffe. So now that we've filled out this box, when we run it, the computer will print out this sentence. Then when it gets to favorite animal, it'll add whatever is inside favorite animal, which is giraffe, into the output. Now notice how the computer doesn't have any spaces between is and giraffe, and that's because it goes straight into giraffe after the end of the S. So to fix this, we can simply add a space. Now the wording of the sentence is a bit awkward. We can fix these later with a bit of debugging. Like we can add A's and all that. But I think I've gotten the idea of concatenation down pretty clearly here. And it's pretty simple to add strings together. Just need a plus sign. You can even add more snippets of a sentence after your variable. So right here, we've kind of just stuck a variable between the sentence. And we have a kind of complete sounding sentence. The grammar might be a bit off. Also in Canada, we spell favorite with a U, so it might look a bit strange to some of the viewers out there. All right. Now the last thing to talk about for variables are naming conventions. So there are standards to how you should be naming your variables, and these are called conventions. In Java, whenever you're naming a variable in code, you should always use camel case. It's called that because the capitalization in the middle kind of looks like a camel's hump, so they were very creative and named it camel case. But if you remember back in our previous lesson when we named our file Hello World, we capitalized hello and world, so both of them were capitalized. That was using Pascal case. And when you title classes in Java, so basically when you name files, you have to use Pascal case. Well, I guess you don't really have to, but it's good to stick to these rules and regulations. There are a few no-nos in naming. For one, you can't use spaces to separate your words. You also can't use numbers, or you shouldn't use numbers, because spaces and numbers have special meanings to the computer, so it might make it confused. Alright, so we're into the last topic of today's lesson, which is binary. Now, binary code is a 2-digit numbering system that represents text or instructions. Now, the computer has to use a 2-digit system because it can only store memory in one of two ways, on or off. On is usually represented by 1 for us, and off is 0. So I'm going to pull up a new window just so I can show you guys what counting in binary is like. Alright, so here I have a little chart, and I want us to think of this as the computer's RAM. So each box here is one little storage space where the computer can put either a 1 or a 0. And these are called bits. So, bits. Now when we have a group of 8 of them, we'll call it a byte, spelled with a Y. So right now I have 1 byte of storage space. Now for a computer, when it starts counting, for us, with our 10-digit system, we would start at 0, then we would increase by 1. So we'd go to 1, and then 2, 3, 4, 5, 6, 7, 8, 9. Once we reach 9, we've kind of run out of symbols, so what we do is we go back to 0, and then we add a 1 to the next place value. Now for the computer, it'll be a bit more difficult, and it's not something we're used to because it's only with 2 symbols, but it's essentially the same process. The computer starts at 0, then it goes to the next number, 1, and once it's reached 1, it's run out of symbols. It doesn't have another symbol, so what it does is it moves that to the next place value, and then over here it goes back to 0. And then as it continues counting, again, it goes to 1, and once it's at 1, 1, they're both full, so the computer moves both of these to the next place value, and this becomes a 0, this becomes a 0 again. Now again, it starts counting, 1, and it's run out of numbers, so it moves it to the next place value and goes back to 0. You get the idea. So for us, each of these little bits are only capable of storing a very small amount of data. Well, for us it is a small amount. What it looks like is this. With this first bit, so 2 to the power of 0, the computer can only count up to 1. So let's add a row at the bottom. Here it can only count up to 1. Because it can hold 0 and then can hold 1 and then it's run out of space, right? In the second place value, it can only count up to 2. Because it'll go 0, 1, 2, and then it's run out of space. With this third place value, it can now count up to 4. And so on. With more memory, the amount of numbers it can count to grows exponentially. So here it can count up to 8. Here it can count up to 16. Here it can count up to 32. And here you can count up to 64, and then 128, and then 256. And so 1 byte of data is capable of counting up to 256. That means the computer can store any number smaller than 256. But if you have a bigger number, it'll run out of space, and so it'll run out of space, and so it won't be able to store that number anymore. Now, let's say we wanted to write the number 153 in binary. What would that look like? Well, we'd start off at 153 and then we'd choose the biggest number that it could, or the biggest number in our little placeholders that it could be stored in. In this case, it's just 128. So we'd put 128 in here. And so we've stored a 128, which means we have quite a few numbers left. What do we have next? If my math is correct, after 128, we still have 25 left to store. So the next biggest thing we could store in here would be 16. So let's put a 1. Oh, I guess it would also be good to clear this out, wouldn't it? Okay, we can store a 1 of 16. And so after we've stored that 16 down, we just have 9 left. So with this, we can store an 8, which means we just have a 1 left, and we can put that 1 right here. And so right now we've stored a 128, a 16, an 8, and a 1, which all add up to 153. And that's how a computer would store the number 153. It would be 100110001. So it is pretty long, but a computer has so many bits in its RAM, so it's not too much of a problem for it. Alright, let's go back to our slides. Now, the computer doesn't just have numbers to store. It has to store all sorts of things, letters, characters, symbols. All of those have to be stored in a system of ones and zeros. So you might be wondering, what the heck? How does it store all of that? The answer is surprisingly simple. It just needs a lot of bits, and I mean a lot of them. The average phone today has around, give or take, 128 gigabytes of data. Some have less, some have more, but these are gigabytes we're talking about. If you're curious, you're free to Google up how many bits make up a gigabyte. I don't know that off the top of my head, but I'm certain it's a lot. So, that's it for binary. That's as much as we're covering today. It has been quite a long lesson. I'm glad you stuck around. Here I've included a little chart It's called an ASCII chart, and it kind of shows you what some of the symbols are in ASCII code. So that's it for this lesson. Thanks so much for joining, and we look forward to seeing you at the next lesson.